Chelsea, did you get the stuff I sent late last night?
Yes, I'll put it on the website right now.
Yeah, so Chelsea will upload a few things for this assignment, and you can see my screen okay?
Yes.
Okay. I'm not going to read through all of this, but this is a document similar to the other projects that just outlines what I want you to do for this next assignment. And there are 2 references that I provided as well that might give you some background on this fault that we're going to be talking about. And the references actually focus a little bit south of where we're going to be working. So it's not exact location, but it is the fault system. So we're going to be mapping a fault along the Western Basin and Range, along the Sierra Range front. It goes by a bunch of different names, but it's known as the Carson Range Kings Canyon fault system. And some people link the Mount Rose fault system with it, which is kind of somewhat along strike. And so what we've done is put together a DTM, and we've made hillshades and slope maps with that in previous homework assignments. And so we're going to do that again just to get some base maps for you to work with. So you'll download the DTM and start looking at it. Let's see, I can also open this one. Yeah. And so before I get too into the assignment, I just wanted to show a few photos of this area so you're kind of familiar with what we're going to be getting into. So this is Washoe Valley over to the left. It's a closed basin with a internally drained basin, so there's a lake in it. I put where some faults are in red, so I'm standing on the Mount Rose Ski Resort looking down. The Mount Rose is a really tall mountain, and it's been created by active normal faulting along its eastern side. So there is a sharp range front. It's somewhat obscured by the trees right here on the left side, but you can kind of see it marking the edge of the valley on the south side there. So I showed this slide the other day. This is the same fault system a little bit further to the south where it's known as the Genoa fault. And so I showed this nice scarp along the base of the range front, and I talked about triangular facets. Okay, so there's about 1,500 meters. I can't remember exactly. 1,500 feet of relief across this thing. So it's and the basin is 1,000 feet deep or more. So it's a significant amount of displacement across the fault. Here's a little map showing how someone else has mapped it. So here's a few photographs looking across Washoe Valley. Now I talked about taking pictures from up here by the ski resort, but this is now across Washoe Valley looking back to the west, and there's a pretty prominent range front here. Some things you'll see in the LiDAR are scars from debris flows and landslides, which are these white features right here in the middle of the photograph where bedrock is exposed. And major debris flows have come down onto the valley floor. The most recent one was in 1983, which actually killed somebody and put a bunch of debris on the highway. So pretty massive debris flows, and they show up really nicely in the LiDAR. You'll see those as you look through. There were also glaciers here in the late Pleistocene, and so there's some glacial moraines further up in the mountain that you'll see in the LiDAR as well as you inspect it, and there's outwash plains. There's also a few fans, and this valley is filled by lake deposits, which have, when the lake was a little higher, it's acted to mute the expression of the fault by sort of modifying fault scarps and eroding. Just a couple more pictures from the same area, just slightly different angle, but basically there's a fault system that runs along the range front here. There's faults up in the bedrock as well. And so the main question for you guys when you're looking at the LiDAR is how does it get from this nice range front here? There's a pretty nice range front to the north of your LiDAR data set, but it gets distributed up in this area. And so the challenge is to map it and see how you can bring it through some of this bedrock topography here. This is, I talked about in the triangular facets and where there's scarps along the range front, sometimes the base of the slopes get oversteepened. And so this is just a photo looking south along the range front showing this kind of pretty steep slope with boulders on it. That would just be the basal slope of a triangular facet as it, above the fault. So essentially the fault would run right along the base of the slope in this location, and you're going to kind of assume that by the kind of the oversteepened nature of the base of the slope, which will show up as a nice, if you illuminate from the west, it'll show up as a nice shadow contrast along the range front. Here's what a couple of the other scarps look like. The one on the right is sort of in a fan deposit, and the scarp's about 2 meters high. It's not super sharp. Apparently there was an earthquake around 500 years ago along this fault, but this is what the scarp looks like. And in the LiDAR, we'll remove the trees and you can see it in a few places. This is what the scarp looks like on the left in one of the county parks. You can see the elevation difference across the lawn here. The range front is up behind these trees, so there's a scarp that's outboard of the range front caused by faulting. So I showed this the other day as well, showing abbreviations that you can use for geomorphic features. I'm not sure exactly how to do this in QGIS. Maybe Chelsea has a comment, but how to add just text. Is there a text tool? I haven't seen it yet. Just to add abbreviations, you have to make a new shapefile, or can you just add text in the map panel? Do you know?
I will look it up and let you know.
Okay, I put some instructions for some of the things I want to do in the homework, but I couldn't figure that out yet. But anyway, it'd be nice to indicate some of the things like scarp. You may have scarp going along the fault, but some of these other features are also present, triangular facets and grobens in particular. And so, start thinking about how you might categorize the geomorphology along strike. And I'm not asking you to map deposits like we did in the last homework assignment, just fault traces this time around. But you definitely need to think about the deposits because you'll have to write about them a little bit, okay? This is what the LiDAR data set looks like, and I was having problems exporting it from QGIS, so I just took a picture of it so yours will look much better. But I just wanted to highlight a couple things on it. Let me move your faces out of the way so I can see. But there is a range front here. Moving along, there's also some stuff up in the bedrock that you'll look for. Okay, it's quite a long area. It's about the size of a topographic quad, a 7.5 minute quad, 1 to 24,000. So it's a sizable chunk of real estate. But I asked you to spend about an hour mapping the fault traces, try to figure out how to get the fault through this bedrock and what its expression is up here. So in the north part, this is one of these big canyons that has some glacial moraines high up in the canyon, and a big outwash fan coming out of the mouth of the canyon. And then down here, when you zoom in, you'll see, I think I have a picture next, some of these debris flows I was talking about. So I apologize for all these lines because I took photos of these. So there's the reflection of my flash right there, which reminds me that it's still smoky here. This is what the sun has looked like where I live for a couple weeks. But anyway, so here's the mouth of a canyon with some sort of fan surface coming out, and there's a range front scarp here. There's also a scarp in front. So I talked about last time how you can preserve fans by having offset across the fault, which drops the valley down and elevates the fan surface. But you also notice there's another scarp further up the fan as well, right in this area. So you kind of look for these shadows as you go through the data. This is up in the mountains. There's more scarps, and you have a nice smooth bedrock surface here and a shadow kind of cutting across the grain of things, which is an indication that there may have been some faulting across there. Okay. Here's another location. All these little circles are houses that weren't filtered out of or properties, of a suburban development. But what you can see coming through there is so the stream moves sort of upper left to lower right, and there's these lineaments cutting across that grain. So some faulting there, and maybe some graben formation. So those are some of the features in this data set that you'll be looking for. And let's see. Okay. Let me put this back up. And so there's just at the end of this document, which Chelsea will post later, there's a little summary with some references and a little summary of the fault system. So it's called Background on the Carson-Kings Canyon Fault System. Just gives you some information on the amount of displacement. I said feet earlier, but more than 2,000 meters of down to the east normal throw. I'm reading it right here. And 1,500 meters on the range front, and over 1,000 meters in the basin. So there's quite a sizable amount of offset across this thing in the late Quaternary. So part one is just a map on the hillshades or slope map that you generate, and use different types of lines where you're certain, where you're dashed, dotted, or question marked to indicate your certainty that it's a fault trace. Okay. And you'll turn in a screenshot of your map, and hopefully it'll have some kind of legend. You can generate the legend any way you want to, either in QGIS or just type it up in Word or something like that, or another graphics program. So I asked you to turn in a screenshot just because it's easier, but I also put in here that if you're, because it's a whole quad, if your screenshot is just too small to really see the fault mapping, you can zoom in and take 1 or 2 screenshots of pieces of it, okay? And just turn them all in. The next thing, so we haven't done much work with profiles, so I want you to install a plugin to your QGIS, and I have some instructions in here on how to do it. I used one called QProf, but there's a bunch of different profile tools. Chelsea, have you used profile tools in QGIS?
I've not.
Okay. Well, I played with it and found it, and so you just go to the Manage and Install Plugins, and you type in profiles or profile, and a bunch of different options will come up, and different developers have developed different plugins to make a profile tool. And so this is what it kind of looks like when you open it up. When you install it, there's a little icon on your toolbar. It's this little green thing that has the shape of a profile. And when you click that, it opens this little window. And then you have to go in to the add layer, so it knows what layer it's going to interpret the profile from. And so you'll have to go over into your layers option or layers window and just click once, highlight the layer, and then click add layer. And you want to do that with the DTM, so that has the elevation data. And then you click once and then click twice to end the line, and you should see a profile drawn. Okay. And if you hover your mouse above it, it should say the elevation of the profile as you go along it, but you can also read the elevation on the axis. And so I described that in there as well, how to do that. So I want you to play around with profiles, because profiles can teach you a lot about the topography and where scarps are big, where they're small, what the what it looks like in a profile. Helps us kind of think about where the fault might go. So I asked you to turn in screenshots of 3 profiles. So kind of like this example here, but 3 profiles, and indicate on your map where those profiles are. Okay, so a short one and a long one. Sometimes with a really long one, you can see variation in the topography that might indicate where there's breaks and slope, where the fault might be. When you compare that to your map and the LiDAR with the profile, you go, oh, okay, well, that might be a spot where the fault is. And a shorter ones on some discrete shadows will give you an indication of kind of the shape of the scarp in the last couple of earthquakes. Okay, and then it's just a summary, and this is, I put a lot of stuff in here. This is mainly just to get you thinking, write a 3-paragraph summary of the mapping and the profile efforts. Just describe the tectonic geomorphology, describe the profiles. I put a bunch of questions in here, mainly just to get you guys to think, what does this all mean? How does the fault change along strike? So don't get too carried away with the writing, but think about some of these questions that I've posed in each paragraph, and how you might think about what your mapping means, and how you might be able to answer some of these questions or pose some ideas of how the fault is expressed through the topography. And I'll be around on email to answer any questions about this. If something, if you can't get the toolbar to work or whatnot, but it was pretty easy to install the plugin for profiles. So you should be able to do it, no problem. Any questions on the homework? It'll be due next Wednesday. But, spend an hour mapping, and then, generating profiles is pretty quick, but then just think about your profiles and how they, so you don't want to do them all in the same spot. Do them in a few different areas so you can kind of get a characterization of what the slopes look like across where you've mapped faults. Does that make sense?
Oh, yeah.
Oh, yeah. And so, part of the thing about this is, I showed some examples of screaming normal faults where it's like, it's obvious. It's right along the range front. There's these massive facets and, big scarp along the base. It's really obvious where it is, like in the Wasatch in Utah or something like that. But it's not always that easy. And so this is to get you to think, like, why don't I see anything here? Where is it? But it's got to go through there somewhere or somehow, whether there's some really distributed wide zone with real subtle scarps, whether it's stepping or bending. So it's just meant to get you guys to think, like, wow, I can really see it here, but I don't know where it is here, but I know where it is here, and how do I map it through, right? And you may map it just with some dotted lines or some queried lines, some approximate lines, but there are a lot of features, and we'll go over it when we go over the homework next time. But I'm really curious to see what you come up with. But it's one of the most active faults in the basin and range, so it's definitely carrying a lot of slip. It's generated a lot of topography. So the earthquake's got to get through the data set somehow. And so I want you just to think about that. Okay.
I had a quick question. So until we figure out if there's a text tool on QGIS,
Yep.
Can we use the same program that we make the legend for, like Illustrator or something, to maybe annotate it?
Yes. I mean, everybody has different computers and different software and different graphics programs. So whatever works for you is fine. I taught a field camp over the summer remotely, which was a challenge, but we even had people just printing things out and taking pictures of it with their phone and emailing that to me. So whatever works for you, everyone has different computing facilities right now. If we can figure out some way to do it in QGIS, I want to learn that myself.
I'll look today, and I'll send instructions to the whole class. So you can do it.
There's got to be a way, and there's also a way to export. I've been playing around with that and not having the best luck. You have to make like a canvas.
It's a little bit involved, but yes.
Composition and then load a layer into it, or yeah. So I've been trying to figure that out too. So screenshots work for this, so we can just at least see your mapping. And adding some annotation with some abbreviation for the geomorphic features is really great. But if you're having trouble with that, just describe it in your write-up. Where these features are and what you saw. But
spend time on the mapping, not on the worrying about the technology.
Exactly, and we're all kind of learning with this, and it's cool, and it has a lot of functionality that we're figuring out, like this profile tool that I found, which is really helpful. So just adding tools to your toolbox of things that you can use.
Okay, thank you.
Anything else?